My name is Yuzhu Lu, and I work on front-end 3D graphics. So the talk I'm going to talk about is about some of the new stuff of 3D graphics in front-end, including some of the cool stuff like 3D-scopic rendering support and NPR, non-photorealistic rendering support. My name is Yuzhu Lu. I work on front-end 3D graphics. So today I'm going to talk about a few new stuff we're currently working on, and which is still in experimental stage. And first thing I want to talk about is single pass depth peeling. It's all about the 3D transparency rendering. Why it is so expensive is because of the depth order of each pixel matters to make it correct. So some sort of sorting has to be involved in. And the original version, we use the BSP tree. What it does, it divides the triangle into very small enough pieces and then sort them before we send it to renderer. And the downside of that is, you can imagine they use a lot of memories, and of course CPU spins for that. Then we come with the multiple pass depth peeling. We don't have to sort it, split and sort it. What we do is just doing many join the same object many times. So each time it will appear one depth layer off, and then put them together after everything's done. And the downside of that is, yeah, you can see that you have to render the object many times. And now the new technology allows us to do the single pass depth peeling. So just render once, peel everything, and render it, and that's done. Here are some of comparisons over here, and the numbers I collected is on my notebook. You can get better numbers with desktop. And I'm not going to write it right now because the BSP tree might lock the notebook for a while, and we are short of time. But I do want to show you something else. If we pick up some random results. Let's run it first. And if we hold on the control key and try to interact with it, here it is. We now support 3D stereoscopic of rendering. And it is built in for Windows. And you can rotate it. You can zoom in, zoom out. I see the cursor there. You can also translate it as well. You can minimize it. So it just doing just exactly the same thing as in the notebook. And it is belong to the graphics. If you delete the graphics, it will be gone. Yeah. So yeah. So let me show you a little bit more fancy example. And this is a volume rendering. Has some lighting on. And if we enlarge that a little bit, so I can see that a little bit better. And we do the same thing. So it works with volume rendering as well. And if you have glasses, you can get a better depth perception of this. And if you want to try, there's some glasses over there I want to try in person, talk to me after the talk. So here comes the next question. How do we control different stereotypes? The answer is pretty straightforward and simple enough. And if you go to NVIDIA control panel, there's some interface allow you to turn stereo on and off. It will take a while. Yeah. So and if your hardware support, there will a list of glasses you can choose from, and select that. And you can also turn it off, and then reload the Mathematica. It will be just work as it expected. Okay, let's move forward. So next, talking about non-photorealistic rendering. What is NPR? In the computer graphics scope, the rendering mainly have two directions. One is the photorealistic rendering to make 3D graphics render as true as possible. That involves a lot of complicated lighting model. And typically, it will use a lot of computer power for that. The other direction is totally opposite, is render objects in artistic style. For example, like a sketch, a water, a color, and ink, like a hand drawing, something like that. So we are going to provide a collection of NPR functionalities. You can ignore this because these we are going to be have it built in, and you don't need to worry about that. And I listed it over here just to let you know how it is implemented. And so for you to use it, just use like other directives. You can use it directly, apply it to any graphics. For example, it is here. Let's make it bigger. And if you doing rotating, it just works as expected. And everything's running in real time. And you can also apply parameters to it. Like, for example, here you can define the color of the outline, and it works as well. If you want to apply it to something else, like this is a different model, and it just works. So which means you can use it just like other normal directives and apply to any graphics. So tone is very popular for in the movie and the TV industry, and you can do it in our 3D graphics as well. And this is the default color assigned, and you can also define the lighting direction and also the tone colors yourself. And like it here, you can also specify lighting directions. So you can apply different styles to different objects, and it just works. 2D sketch, and we now have some code to let sketch pattern apply to field curve, and so you can define the patterns yourself, and of course you can apply to something any graphics defined. This is another converted. Currently, you need to convert it to field curve because field curve takes the vertex texture coordinates. But we're going to move forward and try to add more to the face-based polygons, and so that they can be applied directly. And 3D sketch is a little bit more tricky because it involves some lighting computing to make it look better. Okay, here it is. So let's define. We have some predefined features like this called a 3D sketch, and you can apply. What we do is apply this directive to any function, any 3D functions, and like it does. And but you need to feed in sketch style. What is sketch style? It is basically let me try. Okay, it's just a texture has different sketch lines there. On the bottom, it's thicker, so it can tell. It can apply to different lighting conditions. So here is an example. I can see it will change when the lighting direction changes. And here's another example. In this example, we applied two styles. And this style, it's just a bunch of points. And yeah, I can totally get different feelings of that. And we're going to provide a bunch of collections of this sketch pattern in the library in the future, but we will also open that up so that you can specify yours. And here's another example applied to a sphere. Yeah, so the idea is just to make it work for any 3D graphics. So next, you will notice that the NPI, most of the NPI stuff is implemented with a keyword called surface appearance. What is surface appearance? It is something new feature we're currently working on. What it does is it will expose the custom low-level OpenGL shadows to user and also to developers. So you can do a lot of flexible things. For example, customized rendering. And it works with both 2D and 3D graphics and works on all platforms, including the software case. And we are following the GSLang 1.2 standard. It is guaranteed to work. And here are some examples of 2D examples. Like this is image like edge detection. Of course, we can do a lot of fancy things with the building functions. But what I want to say that here, it is the algorithm is applying when it is rendering. So there's no memory cost. There's no CPU cost at all. So it will be very good if you want to do some video processing. And there's a lot of flexibility there. And you can also do some GPU based on that. Here is the example. You are doing some computing as you're rendering things. You can do a lot of physics simulations. It is just fast. And of course, we have it. The tone shader is for 3D. We already showed that, and you can change the lighting directions, the colors. You can also try to combine the 2D and 3D together. What's the benefit of that is you can do custom rendering for 3D, and after that, you can do some post-processing on that. For example, like edge detection or something else. Okay. Here's an example, and so this is custom rendering. This is a post-processing. So there's a lot of flexibilities. I also want to show we have a very good message system. So if there's something wrong here, the message will just pop up. Let me just show you something a little quick. For example, if it is running. Yeah, you can see, okay, something is wrong over here. It is directly from the low-level hardware, and we received it, and then I reported it to user. It is very useful for debugging. And beyond that, we are also having an object called a GRView. What is a GRView? It allows you to use low-level OpenGL language directly in mathematics. And so there's a full set of 140 OpenGL ES2 functions implemented, plus a bunch of utility functions. And you can use all of the mathematical matrix operation functions and the data set of that. Also a lot of other functions available. And also it has same the compiling link and running time arrow for debug. And here is an example, simple example. What it does, simple enough, it does just define a viewpoint and clear it with certain colors. Yeah, this is the error message from previous shadow. And this is bug, and let's just try to ignore that. So if we're going to change it a little bit different color, it just works. And so here you can, what you can do with it, you can define the shadow yourself. Of course, same as like the feature we talked about before. And by that, you can do more things. You can define the rendering type. It's yourself. You feed in the data. These are sequential OpenGL language. And then you can do things like current graphics language you cannot do. For example, view in view. It's simple enough, but it just works. So you can also define your own customized renderer yourself. So here's the example. Here you define your own lighting. All lighting functions and the functionality. Also, you define the mouse interaction yourself. And what you do is feed in data. It just works. So this small piece of code, it is just a small customized renderer. You define it yourself. And you can be more aggressive. For example, if you want to do something ray tracing, and you can do that as well. This is a small piece of example, and so you can do a lot of cool stuff. So that's roughly my talk. I want to say that these are different directions we are going, and definitely it's not done. It requires more effort on that. So please let us know what you like better, and we will put more effort on it.